Okay, so on this problem, we're wanting to simplify the complex fraction. So this is what we call a complex fraction because it's like fractions over fractions. So it's complex. That's why they call it complex. It is complex. It's ugly. These come up all the time in when they do real life engineering, physics, chemistry, things where they use math, statistics, and on and on you go. Business. You get real life things that lead to fractions over fractions, and that's just ugly. It's complex. We want to simplify it. We want to make it cleaner. How do we do it? Well, because of the adding, subtracting, we're not allowed to just, we'd like to just grab this guy and just go, look, just flip it, right? Because it's divide. We know dividing by something is the upside down of multiplying. So can't we just grab this and just like flip it 9 over 8 and x over 1 or 1 over x or whatever? No, all that's illegal. So let me write that. And it's because of the adding, subtracting, you probably know. So step number 1, you say what you cannot do. You cannot flip added, subtracted items. It's just not true. Doesn't lead to the truth. So instead, what do you do? Instead, you multiply all the terms, top and bottom, by LCD over 1. And what's the LCD? LCD is one of each type of item under a small bar. So I look under this small bar and this small bar and go, oh, okay, 7 and 9. That's what it is. So the LCD in this case is 7 times 9. So, but I'm going to multiply LCD over 1. So LCD over 1 is 7 times 9 over 1. So what I'm going to do here, let me bring it down where I got a little more room. What I'm going to do, 5 over 7 minus x, 8 over 9 plus x. Okay, so I'm gonna multiply by the LCD over 1, right? We cannot flip. Instead, we multiply by LCD over 1. So I'm going to go, all right, got it. So I'm going to go 7 times 9 over 1. 7 times 9 over 1. Like that. Just like that. Multiply top and bottom by LCD over 1. Now, what I just did is missing part of the story. I have not really done everything I'm supposed to do. What do you mean? Isn't that what they said to do? No, but that's a common mistake lots of students make. But technically, these words have not been followed. What words? What words have I not followed? Does anybody see? There's something in those 3 lines I just underlined that I'm not doing.
The other side, the x's, you didn't multiply them by the LCD over 1?
Very good. Yes, very good. It says all terms. Thank you. Excellent. All. That's so important. Yeah, exactly. So you got to go 7 times 9 over 1 here and 7 times 9 over 1 there. I know it's tempting to forget that because you think, well, that's not a fraction. It's just this one's good. Well, it isn't our choice, right? Whatever we do to the top of a fraction, we must do to the bottom. Otherwise, you've changed it, and you can't change it. Right? You might think you're totally changing. No. When we're done, it'll look different, but it's the same value. We haven't changed the value. It looks different, but the value will be the same. So you must do the same thing to all the terms on the top and all the terms on the bottom. That's what makes it legal, so to speak. That's what makes it so that you haven't really changed the fraction. You've only changed the way it looks. All right, so I'm trying to probably camping on that too long, but I just want to make sure you don't forget that. All right, what's step 2? Cross, cancel, right? What was the whole purpose of this? We wanted to clean it up. Well, here comes the cleanup. Bye-bye 7s, bye-bye 9s. All right, well, and what does that leave us with? Okay, so now we go to the next line. It's going to be much cleaner. All right, so here we go. What's left in this vicinity? Well, 5 times 9, 45. Minus, what's left in this vicinity? 7 times 9, which is 63x. You don't, that 1 underneath, right? Does this 1 here doesn't do anything, doesn't matter. What's left in this vicinity? 7 times 8, 56. The 1, again, the 1, dividing by 1 doesn't do anything. Plus, what's left in this vicinity? 7 times 9, 63x. Again, the 1 doesn't do anything. Okay, so there we go. That's much, much nicer. Now, can we do any more? Well, yes and no. I'm going to give both answers. Yes and no. What do I mean, yes and no? Well, I'll say this. Last step, which is really going to, unless I'm missing, it's going to do nothing. Try to factor top and bottom to possibly reduce. You see a couple of try and possibly, meaning to reduce. I'm not sure it's going to work. So let's try it then. We can go a little ways, but I'm not sure it's going to do anything. So on the top, I could factor out what goes into 45 and 60. Use your calculator if you're a little rusty. I think a 9 goes into both of them, right? Yeah. So I can put a 9 in the front, and that leaves 5 minus 7x, right? That equals 5, that equals 7. So like that, so far so good, because 9 times 5 would be 45, and 9 times 7x would be 63x. Now, what about on the bottom? On the bottom, what these guys are both divisible by 7, I think. 7? Yeah. That leaves 7, that leaves 8, that leaves 9. So take out a 7, and that leaves 8 plus 9x. I think I did that right. So in other words, let's double check. 7 times 8, 56, yeah. 7 times 9, 63. 7 times 9x is 63x. Yeah, did that right. Okay. Now, does anything cancel here? So we did factor. We factored the top and the bottom to possibly reduce. No, 7 and 9 can't cancel. These guys can't cancel. You think, well, cancel the x's. No. You can't cancel added, subtracted items. So no. All right, well, then that's just it. So our final answer then is just right there. Now, really what that means is this would have been fine too. I'll say either is good, either this answer or that answer. Now, why? Well, because this didn't really simplify. Even though we did factor out, nothing actually canceled out, right? So really, they're both equally simplified. So both answers are good. The purpose of factoring top and bottom at the end is to possibly reduce, and it didn't reduce. So it's okay. You can just leave it like that, or you can leave it like that. That's what I'm saying. Both answers are totally great. They're fine. They're good. Either one. Let me double check real quick, even as we speak here. I'm going to go on and check out the system to make sure, because that's I'm telling you what's true mathematically. I want to make sure they've programmed these questions true to that math. Let me say. Right, so they did it that way. I'm pretty sure they will have. Let me see. Top, I could take out a 10, and I'm just going to double check it here. And that would be 8 minus 7x, right? Over, and that's right. And then the bottom, 7, 9 plus 10x. 9 plus 10x, 6 plus 7x, right? And let me submit. Yeah, they're good. They programmed it correctly. It will take either one. I tried both different answers. I tried both answers, and it took them both. Yeah, so either one is totally good. And again, why you might think why? Because nothing canceled. In either case, you can't cancel. And you can't cancel these 63s back here. Right? Why can't I cancel those 63s? Because they're added, subtracted. Remember, we can never cancel added, subtracted items, only multiplied items. So that's why we factored, but then nothing nothing canceled after that. So really, it didn't matter that we factored. It's okay. You can leave it that way, or you can leave it that way. Both are equally good because in neither case can we cancel anything. So they're both done, so to speak. Right? Something's only not done when there's things you could cancel out, but there's nothing we can cancel. They're both done. They're both good, either one. And so remember, on a multiple choice exam, remember that if you're looking at a multiple choice exam and they have this answer or that answer, they're both right. Now, I don't mean I'm not going to give both answers on the test. I'm going to give one or the other. And so you might have it this way, and I've got it that way, or vice versa. Grab it. It's the right answer. Just right. If you have this on your paper and you look up and see that, don't think, oh, Mr. Heron's trying to trick me. No, I promise I don't sit around and have an evil laugh and try to trick you. I just simply happen to leave it this way or that way. But you need to know they're both the same. They're both good. Grab either one that you happen to see. They're both equally good and right. There we go.